Okay, Algebra 2 students, good morning. Yeah, so strange times. What we're going to do is we're going to try to get things back to normal. We're going to try to make sure that you guys, aren't losing what you've learned thus far this year, and we want to make sure that you've got, you've got your brain thinking mathematically over this quarantine. So we're going to go ahead and jump into Chapter 5, and we're going to do, my goal for this week is to do sections 5.1 and 5.2 this week. And obviously, the due dates for these assignments are absolutely flexible. We just want you to, take the time when you have the time to either watch these videos, Google other videos. There's thousands of videos based on these topics that other math teachers have done. But I figured, I would basically go with this section. We're going to go along with the textbook with you, okay? Reading math can be a little tedious, and so just assigning pages to read in mathematics is kind of difficult to do. So I'm going to kind of walk you through 3 examples today. Some of them have multiple steps, and we'll just kind of talk about it, and I might grab a pen and paper and kind of do things a little differently to kind of show you another way to look at it, all right? So I'm going to try to keep the videos for each section to 15 to 20 minutes. This first time it might be a little bit longer, but you guys should be used to something like that. All right, so we're going to start with section 5.1. This is nth roots, radicals, and rational exponents. I've already put out a video on rational exponents. Out of 60 students, I think I got about 3 assignments back, and I think that was that first week of the quarantine. Hopefully there's more of you that will participate in this just because you don't want to lose this, all right? The world keeps going, or it will return to normal eventually, and you want to have the skills to be prepared for that. So when you do these assignments, they'll be, those assignments will be in classroom, and you'll just kind of, you'll turn it in through classroom. All right, we're going to do this through the textbook. The assignments will be through the textbook, so namely it'll be Pearson Realize, and so you can kind of turn that stuff in via that channel there, okay? So there won't be any necessary packets for you, all right? Okay, there was something else I was going to say. It had to do with people turning it in, but maybe it'll come to me later, all right? Okay, so rational exponents and radical functions. Let's go to example 2. Example 1 is more of a pre-calc topic that is unnecessary for us right now. So if you guys would go to your textbooks, this is going to be on page 240, all right? And we're going to look at example 2. This kind of gets to the heart of everything here. All right, so what is the meaning of the exponent of the expression 16 raised to the 1/4 power? Now, I actually covered this in the last video, and what it means is that a rational exponent means that this is actually, you're doing 2 things simultaneously. You're raising 16 to the power of 1, but then you're also taking its 4th root. So you're doing 2 things at the same time. Now, to interpret a rational exponent, look at what happens if you extend the properties of integer exponents to rational exponents. All right, so here we assume the power property. Now, this is kind of the strange way that they do it. Okay, they see 16 to the 1/4. What they do is they convert 16 to 2 to the 4th power. All right, now that is just previous knowledge that you would have had to have known. Now, I have a different way of looking at it. I actually kind of go backwards. Okay, I actually go to this step. So here they can kind of see that 4 times 1/4 actually equals 1, and so 2 to the 1st power is just 2, and so that does equal the 4th root of 16. Let me show you another way to look at this. Let's do it backwards. Okay, let's say that I've got what I want to do is if I have 16 to the 1/4 power or 1/4 power, what I'm going to do is I'm actually going to write it into radical form. Okay, because I know that the 4 in the denominator is a root. Okay, it's not raising something, it's actually rooting something. Okay, so you can kind of, this guy raises things to a power, and this guy is the root. Okay, it will take numbers down. Okay, now what I'm going to do though is, if you remember when we were doing square roots, okay, when we had those invisible 2's, we're looking for things that, we're looking for pairs, right? So if I wanted to take the square root of 64, I know that there's a pair of 8's in there, so that pair of 8's will come out as just one single 8. Now the same thing with this guy. What I do with 16 is I'm essentially looking for quadruples of a factor, okay, of identical factors. And so I got 1, 2, I circle it. There's 4, 2, that's a prime, 2. Okay, oh, that's 2 times 2. So I have 4 2s, so I will actually take those out. Okay, so I like to think of this going the opposite direction. I like to go from the rational exponent to the root and then start looking for pairs, triples, quadruples, quintuples, sextuples, whatever. Okay, so that's just kind of a word of advice there. Now this is basically saying the same thing. This and this, that is what I just wrote. Okay, so here when you get to B, I'm going to do this kind of my way. All right, I'm going to say if 27 is raised to the 2/3, okay. Okay, guys, I'm making videos. Just a second, all right? No, I don't think we're going to have enough time. Okay, so, all right, so what we can do is we're going to look at this a little differently now. I want to always take the root first. Your textbook says it doesn't matter. I can raise this to the second power and get a really large number and then look for triples of identical factors inside. But what I like to do is I like to shrink the number down first, get it as small as possible, then I will raise it to the power. Because you can see I have two actions going on. I have the raising of the second power, and then I have the rooting of the third power, or the third root. And so I like to do this first. I will actually root it first, then square it. All right, it is a great shortcut to do because then you can do it all mentally. Now, if I'm looking for 27, I think, okay, are there triples of a particular factor? And that's 9 times 3. Okay, so I got a prime number there, 3. Then I have 9. I know that there's 2 3s in her. So look, I got triples. I got 3 3s. So this means that I can actually take the third root of 27. Okay, this is all done now. All right, and now I raise it to the second power, and so that gives me 9. Okay, so your textbook actually does do it that way, so that's good. Take that third root first, and then raise it to the power. Okay, all right, so that's example 2. Next here, we've got example 3. Now, example 3 involves something that you might have forgotten, and that is negative exponents. Okay. So here, with 32, now, by the way, this is the rule here. Okay, so this is the rule that we just discussed. Example 3 says evaluate these expressions. So 32 to the 3/5. Now look at what they did here. Good, they shrunk the number. They took the fifth root, and they found that 32 is 2 times 2 times 2 times 2 times 2. All right, so there was 5 factors of 2 in 32, so they reduced it to 2. Then they raised it to the third power. Okay, so they took the fifth root here, then raised it to the third, and that's how they got 8. That you can do mentally. All right, now here's where this is different. Now this is a negative exponent, and so you might have forgotten what a negative exponent does, but it's a very simple thing. The negative exponent is the very last thing you do. All right, so don't let it sweat you. You're going to basically do the same process. You're going to take that third root. Okay, you're going to take the third root, and that we just did that one. That's a 3. Okay, now 3 will be raised to the first power, and that will be 3. So that's here. However, we still have a negative 2. Now, a negative exponent just means that you're going to take the reciprocal after you've raised it to that power. So what you do is you take 3, raise it to the positive 2 power. That's 9. Then, because it's negative, it's just 1 over 9. Okay, you're in the wrong location. So negative exponent means you're in the wrong spot. And so if you're in the numerator, you have to go to the denominator. And if you're in the denominator, you go to the numerator. So a negative exponent just basically means I want it inverted. Okay, I want a reciprocal. Okay, so now 50 to the 3/4. Now in real life, what usually happens is that you don't have these perfect roots. Okay, like 2 to the 5th power is very convenient here. 3 to the 3rd power is very convenient, but you can't take the 4th root of 50. It's a huge decimal. Okay, and that's okay. Actually your calculator can raise things to a power like this. So I'll just kind of show you right here. If I had 50. Let me clear this. 50 raised to the 3 over 4. Okay, 50 raised to the 3 over 4. It's going to give me the decimal. It's going to take the 4th root of 50. All right, and then it's going to raise it to the 3rd power. Okay, you get 18.80. Okay, or you can actually do it like this too. This is what's kind of nice, is that 50 raised to the 0.75. Okay, isn't that what 3/4 is? It's 0.7. It's a 3/4, 0.75. So it'll give you the same number. Okay, so you can have decimal powers. Okay, it happens in nature all the time. In fact, here's our next example. Here's a formula. The Fujita scale rating F of a tornado is represented by this function. So you can see a scientific formula using radicals and powers simultaneously. All right, and so W is the estimated wind speed of the tornado in miles per hour. And what is the Fujita, I said Fujita twice, Fujita scale rating of a tornado with estimated wind speeds of 100 miles per hour. Well, that's easy because they give us the formula. So all I have to do is actually plug in 100 for that capital W. All right. Now I'm going to use a calculator for this, but I'm going to do 100 divided by 14.1. Then, because I am simultaneously raising it to a power while I am taking the root, I can write this as 2/3. That's what that means. Okay. In fact, this right here, we could rewrite that formula as a rational exponent. Okay, we don't have to write it like that. We could write it like this. And so, you know, you use your calculator. What is 100 divided by this? You raise it to the power in a calculator because this is, I can't take the cube root of 7.09 in my head. So I use a calculator and blah, blah, blah. And here, it's a 1.69. So 1.69 classification on that tornado scale. Okay, a 1.69, which I don't believe is actually that powerful. I thought like a 5, like a scale of 5, that's like the maximum number. That's like huge. So 1.69 is actually not that big of a deal for a tornado, I think. Don't quote me on that though. Okay, so last example, we're going to go to example 4. Okay, now example 4, and then we're actually going to stop there. We're not going to solve equations just yet, so don't worry about that. We're just going to do 4, and then we're going to call it. The video is at 12 minutes. Okay, so now what we've got here is, let's say that I want to simplify something that has a 5th root. Okay, now we're going to do the same thing that I did in example 2. I'm going to look for identical factors in groups of 5 and then take them out. Now you might have actually done this before in geometry. So here they kind of rewrote 32 as 2 to the 5th, and so since there's 5 2's, I'm going to take out 5 of those 2's and put it right in the front. Okay. Now what they did here is they actually saw that m to the 15th power is 5 times 3. So what they did is they factored out a power here. Okay, and then this 5th root of something raised to the 5th power canceled itself out. So you're left with 2 to the m, 2 times m to the 3rd. Okay, so this actually simplified to that. Now this is a lot easier to work with than that. Okay, now I would like to show you a different way to do it. This is, I think, superior. Where's my pen? There it is. Okay, I like to look at it like this. I'm going to take the 5th power here. I like to do the numbers and the variables separately. All right, I don't actually like to simplify it like this. I like to look at it like this. All right, I know that I've got 5 2's here, 2 times 2 times 2 times 2 times 2. Okay. All right, so that means I took a 2 out, and what I'm left with is no number anymore. Okay. Then now I have m to the 15. Now this might be a little slower, but I think you're going to be a little bit more accurate. Think of how many quadruples can you take out of 15 m's? M to the 15th means that I have m multiplying itself 15 times in this very long chain. I do not want to write 15 m's, but in this example I will, so I will show you. I'm trying to write it quickly, so I end up giving, okay, so just visually, this is what's happening. I have 15 m's here, so I'm going to take out, there's 1 quintuple, there's 2 quintuples, here's the 3rd quintuple. So this means 3 groups of 5 m's actually come out of that radical, okay? 3 groups, and I'm left, there's no remainder. If there was a remainder, he's got to stay in there, okay? So that's how I like to look at it visually. So I like to take it step by step. I look at the number, then I'll look at the variable. So as we go to this example, just think to yourself, you don't have to even write it like this, okay? I have to take out, let's see, if there's 20 and I need quadruples, then I can actually take out 5 out to the front, okay? If I have 8, then I can actually take out 2 groups of 4, and so I'm left with this right here. Okay, now what you have to do though, all right, you don't have to worry about the absolute value on even powers, because that's always going to be positive. But here's the thing, if you pull out a variable, okay, if you pull out a variable and it goes out to the front, right there, if it has an odd power, then, I'm sorry, if it has an even root and an odd power, then you have to put absolute value signs on it. Because if you have something to the 5th power, if you raise it to the 5th power and it happens to be negative, it will be negative. Okay? So if I took out 5 groups out of here, okay, I'm sorry, if I took out a group there, it would have to be, it could possibly be negative. But because it's a 4th root, it can't be negative, because I cannot take the 4th root of a negative number. It will give me an error, okay? A 4th root of a negative number will give me an error. So let's do this. Let me show you real quick. Nope, do that. Okay, so let's not do that either. 4th root of a negative, say the 4th root of negative 16. Okay, it's going to give me an error because I can't take the 4th root. Okay, so can't take the 4th root of a negative number. So this is just one of those weird little things that is super easy to forget, because I forgot it for a long time. I really did. So if I have an odd power coming out and I'm taking an even root, I have to put absolute values around it, okay, to make sure that it stays positive, because it could possibly be negative. All right, now I'm going to do these 2 examples right here. Okay, so let's do those 2, and then we'll call it. So here's 4a. All right, so 4a is simplify negative 8 feet in the 9. Okay. Okay, so now let's see. I'm going to focus on the number. What times itself 3 times? Now I have a 3rd root, so I don't have to worry about negatives. It's the even roots that I have to worry about negatives. Okay, so how many, do I have triples inside negative 8? Yes, I do. Negative 2 times negative 2 times negative 2 is actually negative 8. So negative 2 will come out. I have 1 triple there of an A. He'll come out. And now I have 3 triples of B's, because I have 9 B's being multiplied to themselves. 1, 2, 3. I'm going to take all 3 out. And that's my final answer. So there's not a lot of work to these at all. Okay. Going to B. Okay. So now I got to be careful here, because I'm taking actually an even root here, and I see a lot of action going on here. So if I have an odd power coming out, I've got to wrap him in absolute value signs, which is, again, super easy to forget. I used to forget it all the time. Even in college, would always forget. So every time I'd see a radical, I'd start sweating, because I knew, oh man, once I started remembering that, oh yeah, okay, look out for that. Okay, so let's see, 256, let's see, 256, I don't know, let's try to make this as quick as possible. 256 divided by 16, 16 times 16, okay. So I have 16 times 16, which is also, now I'm looking for quadruples, so that's 4 times 4 times 4 times 4. So there's my quadruple right there. Okay, so 4 is coming out. I don't have to worry about him being positive or negative. Now, when I have an x to the 12th power, what will happen is that I have 3 groups of x to the 4ths. And so this means that x to the 3rd is coming out. He is a odd power coming out of an even root. So he will be in absolute values, okay? Because he's got to be positive. He cannot be negative. See over here, you were allowed negative numbers if you took an odd root, but a 4th root, you cannot have it. And because it's a 3rd power, he could be negative. Now over here, 4, let's see, I've got 6 of these, okay, 6 quadruples here of y. Now that's actually going to be y to the 6th, okay, but he's even. He is going to be positive, no matter what. So this actually is my final answer, okay, just looking at groups, looking at what I can take out, okay, and remember, if I take an even root and I end up with an odd result, then I have to put that absolute value to guarantee that he stays positive, because if I type it in the calculator and he ends up being negative, it will be wrong, like you'll get an error, okay? All right, so that's the quick gist of it. And so when do you turn this stuff in? Like I said, I'm going to be pretty open to it. Just know that there's going to be 2 videos every week. There will be 2 assignments every week. Okay, and this is really just to keep ourselves sharp, and we don't want to forget things. We don't want to play video games all day. Okay, in fact, I'm getting an Xbox One X today. It's actually on its way. Finally talked my wife into it, so I can't wait. All right, so I'm gonna be playing video games too after I do all my work, though. And I have a lot to do, so I am an adult, so I can't do it all the time. Okay, so that's that. I'm gonna go ahead and put the assignment in Classroom in just a few minutes, and you guys can work on that for a couple days. All right. Good luck to everybody, and be good. Be well. Bye bye.